Well, congratulations. You've made it through chapter 8, all about quadratic functions. And now we get to move on. And you'll see that we're still talking here about quadratics, but now you'll see that it's changed to equations. So I want to give you a sense of what's different between a function and an equation, and then we'll get into how this works. So for one thing, you might remember a function typically has an x and a y in it, like y equals x squared minus 7x plus 10. Or maybe simpler, y equals 2x, maybe it gets this here, minus 1. Okay, so a function typically has x and y in it, or an equation, equations technically can have multiple variables, but typically just has like an x in it. So I might have something like, using this as an example, 2x minus 1 equals 3. Okay. So what that means when you have a problem like this is that you're looking for one answer. Right? We would add 1, 2x equals 4, x equals 2, and we get x equals 2. But if I had this problem up here, I don't just get one answer. I get a bunch of these x, y answers. For example, I'll just pick a couple. If x is 0, y is minus 1. We know how to do that. If x is 1, 2 times 1 is 2, minus 1 is 1. And there's a whole bunch more here. So when you have a function, you end up with what we call, a lot of solutions, maybe infinitely many solutions, as opposed to an equation that has just one solution. So what I want to get moving towards here is away from the idea of a quadratic function and get to a quadratic equation. Something like this, maybe x squared minus 7x. This is the same that was on the previous page, plus 10 equals 0. So you notice now this is much different. First of all, there's only one variable in there. And also it equals 0. And it's kind of weird to think about having an equation that equals 0, but that's actually going to be really useful tool for us to think about in the next few weeks. To get you thinking about this, and we won't tackle this one quite yet, but I want you to think about a couple of ideas here. And I'm going to kind of walk you through a path that isn't going to make a lot of sense at first. I think you're all kind of used to that. But then it should all come back together. Let me suggest this problem right here. If 2 times x equals 0, the idea I want to pose to you here is that if I multiply anything together and the answer is 0, one of these is going to have to equal 0. Right? Because anything times 0 equals 0, and that's the only way I get 0 for an answer. So if one of those is going to equal 0, I'm pretty sure it's not going to be 2. So I would say that x equals 0. Okay? All right. Another simple one. 3y equals 0. Well, I hope you'll recognize it can't be 3 that equals 0 here. So it's going to have to be our y that equals 0. So we have this idea that one of these things has to equal 0. And in those examples, it's pretty obvious which one it is. Here's where it gets interesting. What if you have a problem like this? Well, one of them has to equal 0. But now we get in this idea of, like, I don't know what it is. It could be that x equals 0, or maybe y equals 0. And we'll talk more about this tomorrow. So I don't want to get too far into that. But I want you to understand that when there are two things you don't know, you might actually end up with two different solutions. We're used to getting one solution to an equation. Let me show you this, for example. What if I gave you x squared equals 9? Now, those are numbers that don't equal 0. So I'm going to kind of shift our focus here just a little bit to the idea of how many solutions are you really going to get? Well, you might think about this like, I can take the square root of both sides. That's something legal to do. And I get x equals, well, now here's a problem. I know x equals 3 works. I know that 3 squared equals 9. But can you think of anything else squared that equals 9? Like maybe -3? Yeah, so this is a case where we get two different answers. We get +3 or we get -3. Both of those, if you square, will equal 9. And so we have this idea here that when you see a quadratic because it has an exponent of 2, a quadratic equation, when you solve it, you are going to start to expect now 2 answers and not just 1. So as we look at a problem like this on the top of the screen, you might think to yourself, wow, 2 solutions, what the heck? What might that look like? And that's going to be our theme. We're going to keep coming back to that, okay? Now, I want to show you something kind of cool here. I'm going to switch screens here for a second. This is an interesting little idea that has to do with the connection between a function and its graph and an equation and its solutions. So as you look at this problem, and I'll maybe draw it up on the whiteboard here in just a second, but if you look at this problem, you'll see a function here with a graph, but you'll also see 2 points that have an x value associated with it. So what does that look like? Hold that thought. I'll probably come back to it in just a second, but let me just switch this back here and ask you what you think about this. So we have x squared plus 12x plus 32. This is y equals. I'm going to make a graph here, not a very good one. 1, 2, 3, 4. The graph seems to cross through there. 1, 2, 3, 4, 5, 6, 7, 8. Seems to go through there. We've got a point down here. The graph seems to do this at -4, 0. So ponder this just for a second. Take a good look at this. I'll take you back to the other side. And you can see what this looks like. There's the equation, there's the graph, there's the 2 intersection points, -4 and -8. And I want to give you a way to connect these 2 together, okay? So what I'm going to ask you to consider is turning a function like that into an equation that looks like this. Now, here's the key connection between this. I want you to really get this clear. See this y? See this 0? What I'm saying here is that y equals 0. Everything else is the same. See that? But y equals 0. Okay, now look on the graph. Where on a graph does y equal 0? Isn't it here? The x-axis? So in other words, this equation over on the right here is asking for me to find, let's say, all the values of x. There's 2 of them. Find the values of x that cause y to be 0. Well, guess what? One of them is right here at -4. One of them is right here at -8. So, but how do you get there? How do you find those? Wait a minute. I know something. So do you. We can factor this. Let's go through the process here. What numbers go in front, or what variable goes in front? X and X. See, you wondered why we were ever going to use this. Here we go. Sides are the same. They're both positive. I need 2 numbers that add up to 12, but to multiply to make 32, and I'm going to call that 8 and 4. Oh, 8 and 4. Oh, but it's not 8 and 4. It's -8 and -4. Well, remember this idea I told you back here? Well, that if 2 things multiply together make 0, one of them has to equal 0. Take a look at this. What if this is one of those things that equals 0? X plus 8 equals 0. What do you get when you solve that? -8. What? Are you kidding me? What? Can't happen again, can it? Well, let's find out. x plus 4 equals 0. Subtract 4. X, come on. Are you kidding me? That might be one of the coolest things I've ever showed you. So these numbers right here, -8 and -4, have got a special name in the world of quadratic functions. And I'm going to take you back to the other screen for a second, because chances are you might not like this name. See what it says here? Let me do a quick erase of this. Let me instead go here. See this right here? Find the zeros. There's a couple, like there's a 0 right there. There's a 0, there's a 0, found them. Yay, I won. No, that's not what it means at all. A 0 of a graph is something altogether different. So what is a 0? To be clear, not the number 0. This is what is a 0. It's a value of x that makes y equals 0. Also known as an x-intercept of a graph. When we go back to this graph, I see that the x-intercepts are -8 and -4. I call those zeros. So there are 2 zeros in this problem, and both of the zeros are -8 and -4. Confusing, right? It's an unfortunate choice of terms, but what can you do? So what I want to do is I want to show you now really what comes out to be a third technique for graphing. And it doesn't have to be overly intimidating, although I understand that some of this is intimidating. Some of you are still getting used to learning this way from me. But let me show you what I'm talking about, okay? Here's a problem. How about this one? Y equals x squared minus 7x plus 10. Have we seen that before? I think we have. So what I'm going to do now is I'm going to factor this into x minus 5 and x minus 2, okay? And I'm going to think about this in terms of zeros, not in terms of a function. In other words, 1, 2, 3, 4, 5, 6, 7, 1, 2. And I'm going to think about this in terms of what values of x make this function equal 0. I would suggest to you that x equals 5 will make that equal 0. So that's a dot on my graph. And x equals 2 also will make that equal 0. And now I'm getting suspiciously close to finding my graph. I will show you once again what that graph looked like. Well, no, different problem, right? Different function. But you see that having the 2 x-intercepts means all I got to do is kind of split the difference to find the vertex here. So let me find the vertex. This is going to be a little bit tricky, but you're going to be okay. What number is halfway between 5 and 2? Maybe 3.5? Halfway? 1, 2, 3.5. Oh, what if I did this? That's my axis of symmetry. Not a very good one. But see how I got that split in the middle? So before we used to put a y-intercept up there, find the axis of symmetry, and then mirror it across. Now I get my 2 intercept points really nicely. All I now have to do is plug this in for x and solve for y. Okay, this part is still tricky. Y will equal, I'll give you an easier problem in just a second. 3.5 squared minus 7 times 3.5 plus 10. Now I know the vertex has to be down here because it's an upward, remember this is a positive 1 up here. So 3.5 squared is 1225. This is minus 24.5 plus 10. So I've got, I'm adding these two together, 22.25 minus 24.5 equals minus 2.25. So my vertex is going to be right about that. And now I just sketch the graph from there. So again, what am I getting at here? I'm getting at the fact that finding these two zeros is yet another nice tool, another nice way for us to start making the graph. The hard work here is still maybe finding the vertex, although I know that the axis of symmetry is exactly in between these two zeros, right? This and this distance have to be the same. So I just have to plug in that number to come up with the y coordinate. Let me show you a little bit easier one. Y equals x squared minus 2x plus 8. And just so you know, there's one more after this, and then we're done. So you're going to be not just okay, you're going to be okay. Let's see if we can factor this. I'm going to give you just a second while I mark this up to remember how to factor this. Did you get x minus 4 and x plus 2? Oh, wait a minute. I did something very wrong here. I'm so sorry. This has to be a minus. Sorry, that's got to be a minus. You wouldn't be able to factor it otherwise. That would have been a bit of an ish. Okay, so I want x minus 4, x plus 2. And that's going to give me x equal, remember I said these equal to 0, x equals 4, x equals minus 2. So I go to minus 2 and plus 4. And those are my two zeros. And I know that the axis of symmetry is right in between there. Well, look, there's 1, 2, 3, 4, 5, 6 spaces between these. So if I go 1, 2, 3, that's going to be where my axis of symmetry is drawn. At x equals 1. Notice that there's no easy formula. Yeah, we could go x equals negative b over 2a. Remember doing that if we wanted to. But I'm just splitting the difference between my two zeros. So x equals 1 is going to be the x coordinate of my vertex. So now y equals 1 squared minus 2 times 1 plus 8. Oh, sorry, minus 8. Yep, got it all excited there. It's minus 8. So this is 1 minus 2 minus 8, 1 minus 10 minus 9. 3, 4, 5, 6, 7, 8, 9. We put our vertex down here at 1, negative 9. And we go graphing. What do you think? Okay, and one more. This last one's gonna be a little bit crazy. Y equals x squared minus 81. Now, there's some bad news here and some really good news. This is where I would ask you if anybody sees the bad news, but I will tell you because you can't answer it. The bad news is, this is my y-intercept right here. I don't want to graph that. But let's think about what this looks like in terms of finding the zeros. That's ultimately kind of what we're shooting for here. The zeros are going to be x equals negative 9, x equals 9. So I can do that. I can go 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7, 8, 9. And I can put my zeros right here. Now, the vertex is way down there at minus 81, right? So the graph's going to come up like this, and I don't know where the vertex is. But I do know that the axis of symmetry is exactly halfway between 9 and negative 9, which is right here on the x-axis. So my vertex is going to be 0 and minus 81 because that's where I know the y-intercept is. So look, I get that this part here is a little bit daunting, and I didn't mean to give you this problem to get you freaked out about that. I gave you this problem to get you to see how cool this is. That as long as you can factor, this is a difference of squares, remember? So we use the plus 9 and the minus 9 as our in our factors to get the minus 81. And that leads to two zeros, which allow us to graph our graph. So here's the thing, your book doesn't do a really great job in this first section of getting to all this. So your assignment tonight, and I'll put up here on the page. Oh, I don't know what it is offhand. You have to go back and look in your, oh, I have it right here. I take it back. Page 360, 6, 7, 18, 19, 21, 24, 25. So that's only it's only 7 questions. This will be 9.1. I handpicked these problems so they would cover the things that I went over here, and so you wouldn't have to worry about trying to do weird stuff. Tomorrow we're going to get into this a little bit more heavy work in terms of this property of things that equal 0 and what has to be true and what not. So this is your just sort of an introductory lesson. Do those problems, do super well, and I will see you tomorrow for more of this. Bye.